The researchers' interest in this topic emerged from a broader societal concern that extends well beyond individual student experiences. Across higher education, institutions are reporting persistently high levels of academic stress among college students. Elevated stress has been linked to burnout, reduced engagement, course withdrawal, delayed graduation, and inequities in educational outcomes. When these outcomes occur across large student populations, they become institutional and societal problems that affect workforce preparation, economic mobility, and public well-being. At the same time, social media has become deeply embedded in students' daily lives. Public discourse and institutional conversations frequently frame social media as a major driver of student stress. This framing often influences wellness programming, advising practices, and informal policy decisions. The broader "so what" tension is clear. Institutions are under pressure to respond to student stress, but without evidence about whether social media use meaningfully predicts academic stress. Interventions may target a highly visible behavior rather than a substantively influential one. Understanding what predicts academic stress is a necessary step toward building systems that support long-term student success, equity, and workforce readiness. This concern became more concrete through repeated interactions with students who reported feeling overwhelmed by academic demands while also describing heavy daily social media use. Some students attributed their stress to constant distraction, comparison, and pressure to stay connected. Others described social media as a way to cope with stress or temporarily escape academic pressure. These mixed experiences highlighted a critical limitation in common narratives around student stress. Knowing that social media use and stress co-occur is not sufficient. Institutions need evidence about whether social media use predicts differences in academic stress, and how strong that prediction is. A review of the literature reflects this same tension. Some studies report positive associations between social media use and stress, suggesting that increased use may be linked to distraction or cognitive overload. Other studies report weak or inconsistent findings, particularly when stress is measured as academic stress rather than general psychological distress. Many studies stop at correlation and do not evaluate predictive strength, explain variance, or uncertainty around estimates. As a result, the literature lacks sufficient evidence addressing a practical gap: whether social media use meaningfully predicts academic stress in a way that supports proportionate, evidence-based institutional decisions. This study is grounded in a post-positivist worldview, which assumes that patterns in behavior can be measured, that findings are probabilistic rather than absolute, and that statistical models can be used to predict outcomes while acknowledging uncertainty. From this perspective, the goal is not to establish causal truth, but to estimate predictive relationships and evaluate how much they help explain variation in outcomes. The study is guided by the transactional model of stress and coping, developed by Lazarus and Folkman. This framework conceptualizes stress as the result of how individuals appraise demands and evaluate their available coping resources. Stress arises when perceived demands exceed perceived coping capacity. This framework supports a predictive approach because behaviors that consume time and attention, such as social media use, may systematically influence appraisal processes and coping resources. Importantly, the framework does not claim that social media use causes stress. Instead, it provides a theoretical rationale for why social media use may predict variation in academic stress. The framework also explains why prediction is plausible but incomplete, because stress is expected to emerge from multiple interacting demands rather than a single behavior. The choice of measurement reflects this framework. Academic stress was measured using a standardized academic stress scale, designed to capture perceived academic pressure and strain. Higher scores indicate greater perceived academic stress. Because the scale focuses on appraisal rather than objective workload, it aligns with the theoretical framework and strengthens the logic of prediction. Because the goal of the study is to examine whether one numeric variable predicts differences in another numeric variable, a quantitative approach is appropriate. The study does not seek to explore lived experiences, which would require qualitative methods. It also goes beyond describing association alone by estimating prediction and explained variance. Correlation would only indicate whether the variables move together. Regression allows the researcher to generate a prediction equation, estimate how much academic stress can be predicted from social media use, and evaluate how useful that prediction is. The study uses a non-experimental, predictive correlational design, specifically a simple linear regression design, because one predictor variable is used to predict one outcome variable. This design is required because it would not be ethical or feasible to assign students to different levels of social media use. Social media behavior occurs naturally. Because no variables are manipulated, causal conclusions are not supported, even though prediction is possible. Participants were undergraduate students recruited using snowball sampling. Initial participants were invited through campus contacts and student organizations, and were then asked to share the study invitation with other students in their networks. Snowball sampling was appropriate because it facilitated access to students across different majors and social circles. However, because participants were recruited through peer networks, the sample may overrepresent socially similar students. This means predictive relationships may appear stronger than they would in a more diverse sample, which limits generalizability and must be considered when interpreting results. Two variables were included in the regression model. The outcome variable, also referred to as the dependent variable, was academic stress, measured using the academic stress scale. Scores on this scale represent perceived academic stress, with higher scores indicating greater stress. Internal consistency in the current sample was strong, supporting reliability, and prior research supports construct validity. The predictor variable, also referred to as the independent variable, was average daily social media use, measured in hours. Social media use was operationally defined as time spent on platforms such as Instagram, TikTok, Snapchat, and X during a typical academic week. That a clear operational definition and short recall window were used to reduce ambiguity and reporting error. In regression, these labels clarify predictive roles and do not imply causation. The purpose of this correlational quantitative study was to examine whether social media use predicts academic stress among college students, and to estimate how much variation in academic stress can be predicted from social media use. The research question guiding the study was, to what extent does average daily social media use predict academic stress among college students? Because simple linear regression produces two inferential decisions, two sets of hypotheses were evaluated. For the overall model test, the null hypothesis stated that the regression model does not predict academic stress better than chance. In other words, the model explains no meaningful variation in academic stress. The alternative hypothesis stated that the regression model does predict academic stress better than chance, meaning it explains a statistically significant amount of variation. For the predictor test, the null hypothesis stated that social media use does not predict academic stress. In plain language, this means that changes in social media hours do not change the predicted academic stress score. The alternative hypothesis stated that social media use does predict academic stress, meaning that changes in social media hours are associated with changes in predicted stress. Although these two tests usually lead to the same conclusion in a one-predictor model, they answer different questions. The overall model test evaluates whether prediction is useful at all, while the predictor test evaluates whether the specific variable contributes to that prediction. Data were collected through an online survey administered during the middle of the academic term. Each participant provided one estimate of social media use and one academic stress score. Initial data screening was conducted prior to analysis to ensure that results reflected meaningful patterns rather than data artifacts. Screening included checking for impossible values such as negative hours, verifying consistent units, examining descriptive statistics for extreme values, and reviewing missing data patterns. Cases missing either variable were removed using listwise deletion, resulting in a final sample of 112 students. Linear regression works by fitting a straight line that best predicts academic stress from social media use by minimizing prediction errors across all students. The difference between a student's observed stress score and the score predicted by the regression line is called a residual or prediction error. Regression assumptions focus on whether these prediction errors behave in ways that support trustworthy interpretation. Before interpreting results, assumptions were evaluated systematically. The assumption of linearity requires that academic stress can be reasonably predicted from social media use using a straight line. This was evaluated by examining a scatterplot of social media hours and stress scores. The pattern showed a general upward trend rather than a curved pattern. A residual plot was also examined. If the residual plot had shown a curved pattern, this would have indicated that a straight-line model was missing important structure in the relationship. Instead, the residuals showed no systematic curvature, supporting linear prediction. The assumption of independence of errors requires that prediction errors are not linked across cases. This assumption would be violated if students were clustered in shared contexts such as the same class or instructor, and analyzed as independent. In this study, each student contributed one observation, and there were no repeated measurements. Although snowball sampling involves social connections, the analysis did not model students as clusters or groups. Because there was no formal clustering structure in the analysis, independence of prediction errors was considered supported, though this remains a conceptual limitation of the sampling strategy. The assumption of homoscedasticity requires that prediction errors have a similar spread across the range of social media use. This matters because if errors spread out at higher levels of social media use, predictions would be less reliable for heavy users. This was evaluated by examining a residual plot. If the plot had shown a funnel shape, this would have indicated unequal prediction accuracy. Instead, the residuals showed a relatively even spread, supporting this assumption. The assumption of normality of residuals requires that prediction errors are approximately normally distributed. This matters because significance tests rely on this assumption for accurate probability estimates. This was evaluated by examining the distribution of residuals. The residuals showed no extreme skew. Because linear regression is robust to modest deviations from normality, this level of distributional shape was considered acceptable. The assumption of no influential outliers requires that no single case disproportionately determines the prediction line. This matters because regression can be distorted by a small number of extreme cases. Influence diagnostics were examined to identify such cases. No observations exceeded thresholds indicating undue influence, suggesting the prediction was not driven by outliers. Because assumptions were reasonably met, interpretation of the regression results was considered appropriate. The regression analysis produced a statistically significant overall predictive model. The overall model test yielded an F-value of 12.34, with 1 numerator degree of freedom and 110 denominator degrees of freedom, and a p-value of 0.001. Using the decision rule that p-values less than 0.05 indicate statistical significance, the null hypothesis for the overall model was rejected. This indicates that the regression model predicts academic stress better than chance. The test of the predictor produced a statistically significant slope. The unstandardized slope coefficient was 1.85. The associated t-value was 3.51, with 110 degrees of freedom, and the p-value was 0.001. Using the same decision rule, the null hypothesis for the predictor was rejected. This indicates that social media use significantly predicts academic stress. The distinction between these tests matters. The overall model test indicates that prediction is useful. The predictor test indicates that social media use is responsible for that usefulness. The slope coefficient of 1.85 has a direct interpretation. For each additional hour of daily social media use, academic stress scores were predicted to increase by an average of 1.85 points on the academic stress scale. These points are units of perceived academic stress, with higher scores indicating greater stress. The intercept represents the predicted academic stress score when social media use equals 0. Although 0 hours may not reflect typical behavior, the intercept anchors the prediction equation and allows predicted values to be calculated. The final prediction equation can be stated in words as follows. The predicted academic stress score equals the intercept plus 1.85 multiplied by the number of hours of average daily social media use. Using this equation, predicted values can be compared. A student reporting 2 hours of daily social media use would have a predicted stress score that is lower than a student reporting 6 hours per day. The difference in predicted stress between these two values is calculated by multiplying the difference in hours, 4 hours, by the slope, 1.85, resulting in a predicted difference of 7.4 stress points. These predictions describe average patterns across students and should not be interpreted as precise predictions for any one individual. Model fit was evaluated using R-squared, which represents the proportion of variance in academic stress that can be predicted from social media use. The model produced an R-squared value of 0.10. This indicates that approximately 10% of the variation in academic stress scores was predictable from social media use. This interpretation is critical for decision-making because it distinguishes statistical significance from predictive usefulness. Even though social media use significantly predicts academic stress, most variation in stress remains unexplained. The standardized coefficient was 0.32, which expresses predictive strength in standard deviation units and reinforces that the relationship is modest. A 95% confidence interval was calculated for the slope. The interval ranged from 0.82 to 2.88. Because this interval does not include 0, it supports the conclusion that social media use predicts academic stress. The width of the interval indicates uncertainty about the precise magnitude of the prediction. This uncertainty means institutions should avoid overinterpreting the exact size of the effect. These findings align with the transactional model of stress and coping. Social media use may predict academic stress by shaping appraisal and coping processes, such as distraction, time pressure, and social comparison. At the same time, the modest R-squared reinforces the framework's emphasis on multiple interacting stressors, explaining why prediction is possible but incomplete. Several limitations should be considered. The non-experimental design does not support causal conclusions. Directionality cannot be established. Statistical prediction does not imply accurate prediction for individual students. Snowball sampling may overrepresent socially connected networks, limiting generalizability. Social media use was self-reported, and omitted variables such as workload, sleep, employment hours, or financial strain may influence predictive accuracy. The policy implications follow directly from predictive strength and model fit. Although social media use significantly predicts academic stress, the modest R-squared indicates that policies focused exclusively on reducing social media use are unlikely to substantially reduce academic stress at the population level. A more defensible approach is proportional. Institutions can incorporate digital wellness supports, but they should also address broader stress drivers such as academic workload, advising systems, and mental health resources. Future research should extend this work using longitudinal designs to improve prediction over time, multiple regression models to include additional predictors such as workload and sleep, and intervention studies targeting coping strategies rather than social media use alone. Each of these approaches directly addresses limitations identified in the current study. In summary, this case study demonstrates how simple linear regression is used to predict academic stress from social media use and to evaluate predictive strength. Social media use significantly predicts academic stress, but it explains only a modest portion of stress differences. These findings support evidence-based, proportionate responses to student stress grounded in predictive evidence rather than assumption.